Okay, for those of you viewing this video, this may be the first one you're viewing. This is mostly online students, but anybody can view it. We are in Big Ideas Math, Geometry, A Bridge to Success, copyright 2015, section 1.1, which begins on page 4. The title to it is on the previous page, and it is Points, Lines, and Planes. Those are the tools we will use to try to understand them. And in order to use those to understand other things, you need to understand what we call notation. That's basically what this section is about. It's about how we write things and how we draw things and how we refer to those things in a math problem. So it's all about saying, looking at that, saying that's called this, and write it down correctly. And that thing right there, that's a different thing, and I'm going to call it this. It's about what in this picture and how we are going to agree to refer to it so that everybody's talking about the same thing. Points, lines, and planes. And the diagrams are in your book for you on page 4, and I will be referring to them a lot because they're drawn much more better than I can do. Okay? But I will draw some things up on the board in a few minutes. So those of you viewing this, there's nothing to see. Just listen to my words for a few minutes and get your eyes in the book. Page 4. Generally in this book, if you see things as a core concept, it's got those linked circles. It says core concept. Those would be really, really great things to just read over carefully before a test. It's pretty short. Doesn't take you very long. Make sure you understand what's written in the core concept, and you should do pretty well. First core concept says that we have 3 undefined terms in geometry. They are point, line, and plane. If they're undefined, yes. They are undefined geometrically. What you're going to do, we're going to talk about them so that you learn to recognize them and learn how to name them and stuff like that. We're going to talk about attributes that they have. There's no definition. So, kind of weird. Don't worry about that. We'll just talk about it for a minute. A point has no dimension. It has not got any length, hasn't got any width, hasn't got any height. It is a location. It is simply a location. But we represent it on a 2-dimensional surface like this with a dot. If you really, really, really are nuts and think about this, it has 3 dimensions, the way I've drawn it. It's got length, it's got width, it even has thickness, or I wouldn't be able to wipe it off. It comes out of the board a little bit, right? Everything in our world is 3-dimensional if you want to get nuts about it. But for us, as far as representation goes, that represents a point, and we will always, always label a point with a capital letter, a capital letter. Kind of unimaginative to use A, so I'm going to use J. Someplace near it indicates that we are going to refer to that point as J when we start doing things. We might draw a line through it. We might draw another point somewhere else and connect them. We might do all kinds of things. We will always represent a point with a capital letter. Now, quite often, you're going to see today, you're going to see a couple of lines crossed, and there might be a point here and a point here with names on them, and a point here and a point here, and I'll just be uncreative and write A, B, C, D. Always capital. This also, without making it a colored in point, though, like that I did, that without doing this to it, that is also a point. It's a point of intersection. We might call that T. That's still a point. It just doesn't look like a blob. So there are 5 points on this that I've identified. Okay, y'all with me? Okay, that's a particular special point of intersection. So, okay, let's take a look at a line. A line has 1 dimension, length. That's it. But it also goes along that in that length forever. It has arrowheads at both ends. So when you say line in here, you don't mean just something that's straight. You mean something that's straight that goes on in that direction forever and ever in both places, both lines. Got her? Okay. There may be points on that line, and there may be stuff in between those points that we want to focus on. But the line that you see drawn there, they have it on, and I'm just going to put it up here so it's on the video. But a line has an arrowhead at both ends indicating it goes on forever. We might put a couple of points on it like this. And what was I going to tell you about that? Something. Oh, we would call this point D. We would call this point A, but we would call this line AB. And we would put a bar over it with arrowheads on both ends. And the only reason I put the top arrowhead when I'm writing something is because quite often this is close enough to the A and B that if you do this, it interferes. That's the only reason. You can put both pieces of arrowhead if you want. You'll see me do this. That means, it means it's supposed to be an arrowhead. I just don't want to interfere with my letters. That's only when I write it. When you see it in the book, it'll have both. Everybody clear on that? Okay. You can also call it BA. It doesn't matter which one you put first. And as you can see on that diagram right there, if at one, where one of the arrowheads kind of towards one end, they have a small cursive letter, you may refer to this as line L as well. And it does not have one of those symbols across it. If you use a small cursive letter, whether it's L or P, I know that doesn't look cursive, but if it's up here and I see it, I'll know what you mean. A small letter cursive P or a D, something like that. All small cursive letters refer to lines, and they're usually found near the arrowhead of the line. So there's 3 different names for this particular line: A, B, BA, and L. Okay? They use L a lot because L's what line starts with. Okay, next undefined term is a plane. A plane is 2-dimensional. It's got length and width. A great example of a plane is the thing that's holding your book up, which is your desk. The thing is that it feels like a plane has boundaries. It feels like your desk has boundaries, and it does, thank goodness. We wouldn't be able to move them in here. This is also a plane. Plane of the board, the plane of the page in your books. These walls are planes. The floor is a plane. But in geometric terms, a plane, we represent it with a parallelogram so that we kind of indicate 2 dimensions, but not anything particular. We don't use rectangles because rectangles have other properties we don't want to allude to. We represent it with a parallelogram, but we got to understand that geometrically and theoretically speaking, it goes on forever in this direction and in that direction, forever. Way down deep into the earth, way past it, way up above the atmosphere, way out south and north. But we may be interested in only the stuff that's in this part of the plane, and so we lop off that chunk and talk about that. But it goes on forever. Okay? Now, planes seem to give people the most difficulty. And I'll get back to them in just a minute. I forgot something with lines. I got to back up. Sorry. This is line AB. There's another word that we use. If I put another point out here and call it, I don't know, R, whatever, but that is not on the line that contains A and B, we say that the points A, B, and R are non-collinear. Co means together on the same line. Co always means together. A and B are collinear. Do you understand that word? A, B, and R as a set are not collinear. If I put another point on here, D, then I can say DAB are collinear. DA and B are collinear. DA and R are non-collinear. See the words? We use planar and coplanar and non-coplanar for planes as well. So it's the same context. So if you can see the plane that they have for you in the core concept there, it says a plane has 2 dimensions. It's represented by a shape that looks like a floor or wall, extends out forever in both directions. Now, here's the key. And this is the part people always screw up on. It says, through any 3 points not on the same line. What they should have said, if they understand their own vocabulary, is through any 3 non-collinear points, there is exactly 1 plane. And I don't know if this will make it any more understandable or not, but I'm going to show you. This front side and back side of this tablet right here. I'm going to get this so that people can understand what I'm saying. It's right here, this tablet. Okay. Front and back side represent planes. They're flat. I mean, they can be bent, and now it's not a plane, it's a curve. But pretend they're flat and rigid, okay? If I take these 3 points, remember, a point is just a location, and the locations I'm talking about are the locations at the ends of these pens, where the points are, okay? There's 3 points there. And if I set this on them, we say that those 3 points, among billions and billions of other sets, but those 3 points determine a plane because that plane is balanced on there. It's one of the reasons why a 3-legged stool never wobbles. Even if the seat's scattywampus, it will not wobble if all 3 legs are touching the floor because those 3 points are non-collinear and they're on the plane of the floor. They will never wobble like this. Now, if I make these collinear, and that's a little more difficult. That's really hard to do, actually. I'm going to try. If I make these points collinear, not necessarily the same distance apart, like that, See how they're all pretty much in a line? Yeah. If I try to balance the plane on there, it wobbles. It can't find a home that's going to be stable because they're all collinear. In other words, those 3 points, the way they're all lined up, could represent that plane, but it could also represent that plane, which is different because it's going at a different angle. You see what I'm saying? Could represent this plane. Could represent this one or 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 this one. So these lined up like this collinearly represent millions of planes. So we can't identify the one plane we want to talk about with 3 collinear points. They have to be non-collinear. And as soon as they are, you've got stability, you've got one plane. Because if I try to tilt it now those 2 points on those 2 pins don't lie in that same plane. One plane. Got it? All right. So that's why you have to name a plane with 3 non-collinear points. So in this plane that I've drawn, if I draw a line like this, I draw the line like that. The plane and the line both go on forever. And I put an A in here and a B here. And I didn't draw it big enough. And a C here and a D here. From all that discussion we just had, I hope you understand that you cannot call this plane CAB. You cannot. But you could call it plane CDA. You could call it plane ADB. Let me put the point there. You could call it ADB. You could call it BDC. But the 3 letters that you use to name a plane must be non-collinear. And you have to have 3 letters to name it. With one exception. There's always an exception. If we put, that has no reference to any of these points, any place at all, if you put a capital letter up here in a corner, you may now refer to that as plane P as well. Notice it's not associated with any points. P for plane. And it's a capital letter. In all other geometry books except this one, they have always reserved the names of planes for capital cursive letters. I can't even remember how to write a cursive P. Something like that. Capital cursive letters named planes. But not in this book. All it requires is a capital letter that is not associated with any other point in the plane. And it's usually in a corner. Okay? So you can call that plane P, or you can call it plane CDA, or CBD, and something that involves D. You cannot call it CAB. Better? Okay, so we're just talking about how we're going to name things. Now we're ready for example 1. Things will move faster now that we've got the core concept down. So, anybody else in here sweating? I'm dripping. Okay, all right. Example 1. Naming points, lines, and planes. This won't be very hard. I need you to get your eyeballs on that diagram though, because I'm not going to take time to draw it. Example 1 says, give 2 other names for the line, and as you say line because it's got an arrowhead at both ends. And they give 2 other names for line PQ and plane R. So what's another name for line PQ? Small n, right? That's one other name. Is there another name for PQ? QB. Because the order doesn't matter. Is everybody clear on that? I'm not hearing from very many of you because there's 30 of you. I'm not hearing it now. But it's your job to tell me if you're not following. So you got to raise your hand and interrupt me. Okay, now consider plane R. You see the R down there in the corner that's not associated with any point? You can call that plane R. What's another name for plane R? Anyone?
VPT.
Good. You all see VPT are non-collinear, but they're all in the plane? Can you give me another name, someone else?
VSP.
Sorry?
VSP.
B,
V.
V. S? Did you say S?
Yeah.
VSP. Sure. Yep. How about QPT? They're non-collinear.
Yeah, that Q's off the plane.
That's right. Q's not in the plane. They've got to be in the same plane and non-collinear. Q is not in the plane. Now, comes the next question. Do you all understand that that line QP is not in the plane, but it hits it as it goes diving through? That's what the dotted lines indicate. Do you understand that or you don't? You're all looking at me like I'm not. So let me show you. This is going to be a little bit contrived here. I'm going to take one of the pages off of this and pretend that this is a nice rigid plane. Just pretend with me for a minute. Nice rigid plane. If I take this pen, sorry, over here, nice rigid plane. If I take this pen and run it through like that, can you see that the line that is that pen is not part of the plane, but it intersects it at a single point? Can you also see that if you are viewing this like this, hopefully I'm doing this right, that you can see the top of this, but there's a piece of the pen that's missing that you can't see, and then it comes out below there. The part that you can't see is the dotted part in that diagram. That indicates that this is a line which goes through and slams through the plane and continues on its way, intersecting the plane at only one point called
P.
Yep, and Q is up here. Q would be on the top. And if we put another point down there below where we see the solid part again, well, we got another point on there. Okay, so we can't use Q in any name for this plane because Q is not in the plane. Got it? Okay, moving on. This next part's going to go fast too because I'm sure that you have seen this before, starting in about 4th or 5th grade. If I come back to lines, which I have diagrammed right here, that's the name of this entire figure. These 3 things could be used to name it. However, if I wanted to name the piece that starts here and goes out, and I'm not interested in the rest of this, then we call that AB, and it's a ray. No arrowhead here means it starts at A and goes through B forever. And that's called a ray, not a line. This is how we name a ray. Now, even though it's not conventional, it's still correct. We could also name this BA, the very same ray, but you've got to do this, indicating it still starts at A and goes through B forever. See what I mean? You can't just arbitrarily put letters down and then a ray. You've got to make it start where you intend it to start and go on through the other points. So this one's, both of these start at A and then head towards B and pass there forever. So if I wanted to name this ray right here, going this way, I would need another letter down here, which you can put on. If you put an E in here somewhere, then call it ray DE. Okay? If there's only one point, the point you're starting, and there's nothing else down here, put one on. L has nothing to do with naming this, even though it's in the vicinity. It's just a name for the line. Okay? Let's see. If you take a look at these 2 rays, again, don't look at this. We're looking at this diagram up here. If I have ray AB and ray AD, like that, those 2 have a special relationship. They're called opposite rays in this diagram.
Because they're going like this.
Yes, because one goes in one direction and the other one goes exactly, starting the same place and going the exact opposite direction. They're opposite rays. Okay? So now just because they both have an A in them does not necessarily mean they're opposite rays, but in this case they are. In this picture they are. Now you might think, what are you talking about? Well, let me show you. I'm going to erase this intersect point, this stuff over here. I'm going to show you a case where we have AB and AD in a different situation that are not opposite rays. Might have A, B, and I might have D out here. Now we don't have opposite rays. We've got an angle. Yes.
Angle on a AB ray.
Mm-hmm.
Isn't that be going the other way? Because AB.
Yeah, heads out this direction. What's important is that it starts at A and heads towards D forever.
Oh.
That's what's important in the name, is how you put this, orient this thing. We could, yeah, you're right. We could call it DA and we would point it this way. And it would make more sense according to the picture, but this is still correct.
Yeah.
Okay? AB and AD here are not opposite. AB and AD form the sides of an angle now. Opposite rays, if I go here out this way and then I start here and come back this way, that is also an angle, but it's a very special one called it's really strange. It's an oxymoron. It's called a straight angle. It's 180 degrees. We'll talk more about that later. But for right now, we will call those opposite rays. Okay, look at example 2, please. Give another name for GH. Anybody? But notice I didn't talk about segments. I gotta talk about segments. Sorry about that. If I want to talk about this missing stuff right here in between, I would call it segment DA, like that, or AD. Doesn't matter. But notice there's no arrowheads on either one. It means we're going to talk about the stuff that starts at A and ends at D, or it starts at D and ends at A, and only the junk in between. Everything else that's on this line, we don't care about. Segment. Okay? And so we are going to have to use the bars over the top of the letters. GH is a segment because there's no arrowheads on it. So if you want to call it another name, it's going to have to be HG with a non-arrowhead segment across the top. Name all the rays with point J. Somebody give me one. Name all the rays with endpoint J. Yep, there are 4 of them. Can you all see it? Okay, and then it says, which of these rays are opposite rays? Give me a pair of opposite rays, just one pair. Okay, is there another one? Anybody else?
JG, JH.
There you go. It's pretty easy. Pretty straightforward. Moving on. Just gotta get used to how we name things. Okay, sketching intersections. We're all gonna practice. I think you guys can all draw intersecting lines. That's almost insulting, right? Intersecting lines, they're easy. Intersecting planes, not so easy. And the reason why it's not so easy is because when you have 2 planes which intersect, just a second, I should prepare this for you guys. When you have 2 planes that intersect, like this, these are both 2-dimensional, right? If you have them intersect like this, so now that they've hit each other here, now you got a 3-dimensional object. See it? Looks like a pinwheel sort of kind of. 3-dimensional. And they intersect, by the way. They always intersect in a line. See that line right there? Where they hit? There's always a line where they hit each other. When you cross 2 lines, they always intersect in a point. They always go down by 1 dimension. So if you've got 2-dimensional objects that intersect each other, which is what these are, they always intersect in a 1-dimensional thing called a line. 2 lines which cross, they are 1-dimensional, they cross in a 0-dimensional object called a point. Right? And what's really cool, if you extend that, is if you have 3-dimensional objects, 2 3-dimensional objects, consider a couple of bubbles that you've blown off the stick, get these bubbles there, and pretend they're really stiff. You've seen this, I'm sure. When 2 bubbles touch each other and join, they always intersect in a plane, a circle, right? Can you imagine that? 2 bubbles that hit each other and connect and stay together, a place where they're connected is a 2-dimensional circle. They were 3-dimensional bubbles, they intersect in a 2-dimensional plane. Something to note. Okay. But drawing 2 intersecting planes, so you need a piece of paper and a pencil so you can practice this. And if you want, I will give you paper that's unlined because it can be distracting, or you might be able to use it. We'll try it with lined paper, and if you want unlined paper, I'll get it for you. You need to practice this with me. I'm going to demonstrate one of them, and then we're going to do it again together. Drawing intersecting planes. You're going to need to be able to do this several times throughout the course, and it's nice to have a strategy, because if you just try to, yeah, that looks right. No, that looks crappy. Let's start over. There's a strategy for this. Here's my strategy. I draw 3 parallel lines, and they don't have to be the same distance apart, but I generally try to make them same distance apart, about that, and the same length. Otherwise, it turns out looking like whoever manufactured paper didn't do very well. Okay. And then I'm going to do this in color so you can tell the difference between them. Then I'm going to draw 3 other lines. I'm going to remind myself, I've taught geometry forever, like I said. I'm going to draw 3 other lines parallel to the middle line, but offset a ways. This is what I mean. Here's my middle line. I'm going to draw it parallel to. I'm going to draw one over here like this, same length, approximately, and then another one down here, parallel, same length, about right there. That's a little bit long. You might want to use a ruler if you want. You're going, holy crap, that looks terrible. It's not. This is how you start. And you'll see as soon as I start drawing the other lines that go together with this, how it all comes together. This, when I lock these together, it's not writing. When I pull these together like this and draw the ones, connect the ends of the black ones, that's one of my planes. See it?
We're just dropping these calculators off.
Eyeballs up here. Connect the black ones together, and then these ones that I drew that were off, if we connect those along the ends, grabbing that one in the middle that I made them parallel to. Can you see the intersecting planes? Now, what ones do I dot? Which parts can you not see if these were opaque papers, meaning you can't see through? Do you want to make this part of the red thing the part that sticks out the front? If so, then this will be dotted because you wouldn't be able to see that part of it, right? Is there any part of the black one that you wouldn't be able to see because the red one's lying this way? Right here? Would that be one you couldn't see?
Bottom one.
Here?
Yes.
Can you see this one?
Yeah.
Yep, you can. Do you kind of see it? Do you want me to draw another one with you, or do you want to try following the strategy without me coaching you? Want to try it? They intersect right here in this line. It's that center line of the black one. See what you can do, and see if you can make it look at least sort of kind of reasonably a good drawing. This is kind of a crappy one, but this is a better one. It's easier to do when the space that you're doing it in is smaller than on that board. But that looks about like this one, right? And if you still didn't follow all the strategy, that's why I want you to do it right now, and I'll come around and help you. Straighten it out, whatever. Do your best to draw another one. Try to do it on a piece of paper. Well, try to do it without looking at the other one. Try to see if you can do it without looking at that. And if you can't, then uncover it. Cover it up with your hand and see if you can do it from scratch without looking at what you just did and without looking up here at the board. Some of you that are artists are going, this is stupid, this is easy. And others of you are going, what? Yeah, and then erase the parts that you wouldn't be able to see depending on how you see them intersecting.
Like make them dotted or just erase them?
You dotted would be great, but that's what we normally do. You can erase it if you want it to look more realistic. And please let me know if you're having trouble. I'm walking around and looking, but I haven't seen anybody that's having any trouble. Everybody's giving it a good shot. Good try. Just don't leave them transparent. Try to figure out which parts to erase or at least dot. I usually like to try to make that decision of dottedness after I got it all done. Some of you are kind of dotted as you draw it. That's okay, if you know what you're doing. Anybody need more time? And you can do this to your intersecting planes or not, but I want you to pay attention up here. The red one, I'm going to call that one R for red, and I'm going to call the black one B for black. These are the names of these planes. I'm not interested in the points on them at this moment. I may put some points on them, and then we could name them something else. But right now, I've got the red plane and the black plane, and we will say that they intersect in this line. That's how you say it. The planes, plane R and plane B, intersect in this line. This line needs a name. And so now we start putting points on. This point right here, I'm going to call it Q. This point over here. It doesn't have to be this point. I'm just saying it could be anywhere on this segment. So I'm putting it over here. You can put it here if you want. I'm going to call this T. So plane R and plane B intersect in line QT. You understand all those words? Okay. Let's see what else I was going to tell you about that. That's the intersection. Oh. Does point Q, does it lie in plane R or plane B? Both. What about T? Both. Every single point on that line where they hit each other is in both planes. But those are the only points that are in both planes. Duh, right? Okay. So if I put a point up here, S, and another one down here, these are black on purpose, so I make my point here. Y. Then this line is in plane B. And that line intersects plane R at Q. Do you understand all my words? Okay. And again, I'm doing this in color to make my point here. If I do this right here, and I connect this point with this one, then, I don't know what I'm going to call this A. AT, line AT is in which plane? R, obviously, because I made it red. But can you see that if this was all black, that AT would be in R? And intersect plane B at T? Yes? Question? Okay, all right. And points S, Q, and T are non-collinear? Are they coplanar? S, Q, and T, do they all lie in the same plane? Which one? The black one. Plane B, the black one, plane B, either way. So we could name the black one SQT. Okay. How about YTQ? Could I name it YTQ, the black one? Could I name the black one SQY?
No.
Why? Why not? They're collinear. You can't name them with collinear points. Could I name the red one with A, T, and Y? Could I name the red one with A, T, and Q? T and Q belong to both planes, so yes, I could do that because A belongs to the red plane. See what you're up against? You're looking at three-dimensional things going on that are drawn on a two-dimensional plane, and that makes it hard. So think really hard about what you're seeing and make sure you know which plane you're in, and some points are in both planes, and it's tough. Can be. Okay. Take a look at example 5. It looks like, anybody ever played jacks before? No one's ever played jacks? You get a handful of things like that and you toss them and then you try to pick them up and you bounce a ball. Yeah, you ever played jacks? Okay. That thing looks like a jack. And it's three-dimensional. It's got 3 axes. Or 3 lines that all meet where? All 3 lines meet at B. Okay? Hang on just a second. What do we got?
Invalid dimension? What does that normally mean? Trying to remember. We're just trying to graph a linear function.
You've got your plot on along with a line that has nothing to do with the plot. It's trying
Okay.
to see how they're related and they are not.
Okay, so
Whenever you're just looking at lines, you want to have your plots off. The only time you want your plot on is if you're doing
because that
statistics
was
and trying to
clicked
fit a
right
line.
there. Okay.
Yeah, because that was on. And you kind of get it down your plot, hit enter, it'll turn it off or on, whatever it
Okay.
is. And then when you hit graph, it should go because it was trying to reconcile what was in the stat editor.
And there was nothing in those.
Yeah, it's gone. I don't know how to tie these together. So
Okay. It's been so long since I've
I
had to
know.
do stuff like that.
No, no,
I'm like,
I know.
I can't remember.
I know, bring it back anytime. Okay, all right. All righty. So we got 3 lines that connect the corners of these points here. Now let's see if we can answer the question that's asked. It says the diagram shows a molecule of sulfur hexafluoride. Looks like a jack. The most potent greenhouse gas in the world. Name 2 different planes. Now we're getting to the geometry. Name 2 different planes that contain line R. Whoa, that's gonna be rough because I don't see any planes there. 2 different planes that contain line R. Can you all find line R? I can't. What did I do? Oh yeah, I see it. It's the one that contains D, B, and E, right? Okay. Can you imagine for yourselves 2 planes that intersect in line R, because that will be the answer. So 2 planes that intersect in line R. And remember, to name a plane, you need 3 non-collinear points. Oh, that's rough. Sorry? E, B, F. Yep, that's one of the planes. That isn't a plane.
Yeah.
E? Oh, yes. EBF would contain the flat one. It would be flat. That's how I see it, it's being flat. What's another one? I'm hearing all kinds of things. I heard CBA, hang on a minute, I gotta check it out. C, B, A, You can't name a plane with CBA, they're collinear. CB what? CB E? CBE does not contain line R. So GBD you said? No, GBD's already been named. That's the flatbed.
FBA.
I don't even know the answer to this. I gotta think really hard. Let's see. GBD. Oh, yeah. GBF would work, yeah, GBD, I see it. And the other one would be the stand-up one? No, yeah, the stand-up one this way, which would be something like DBA. If you're struggling with it, struggle. Do your very, very best with it. Maybe get some help from somebody, because I'm struggling a little bit too. And
FBA is one.
yeah, it's gotta contain 3 points of the stand-up one and the lay-down one, not the one that goes, not the, oh, you gotta name 3.
So it's kind of like ACA, GBA.
Yeah, you're starting, once you see it, you go, oh, and you're naming all kinds of names, right? If you're struggling with that, let me know and I'll work with you on it. It sounds like a lot of you have got it, probably better than I do. Okay? We're not gonna do the monitoring progress because we're kind of running out of time. I wanna give you a little bit of time to work on this. Turn the page and there's your exercises. If you had no trouble understanding most of what I said today, you're gonna be just fine, but there's a lot of them to do. Sorry, it'll take you some time, but it may not be very hard. You gotta get really good at this, so that when we talk about this stuff, you're not struggling to try to decide what you're looking at. You'll already know because you practice, okay? Here's the assignment. Are you ready to write it down? So this is section 1-1. And I'm gonna be really rude right here for just a minute. I want everybody to get started right. Can I see your paper for just a minute? Can you see your paper for just a minute? Which one of these is labeled correctly? Yes, it's 1-1, we'll work on this over here, okay?
We have to turn in notes.
If you're gonna start your assignment here, this is just gonna be your notebook, you're just fine. I see, you're starting an assignment here, and I apologize.
No, you're good.
That's right. She didn't do it wrong, but she hasn't done it yet. Okay, so I thought that's where you're gonna start. Okay, so section 1-1 goes in the upper right-hand corner, put your name on it, and then right below that, put these problem numbers. 3 through 24. 27 to 34. 35 to 43. Odd. 56 to 63. And 65 to 71 odd. Now, if you think that's a big assignment, you're right. It's big. However, a lot of these problems are associated with a single picture, like there might be 6 questions about a single picture. All you got to do is look and identify what they ask you to do and move on. It's not going to take you that long, but there's a lot of things to do. Good luck. I'll be right here for the next 10 minutes to help you. See ya.